Our next important topic is Rankine cycle or vapor power cycle. Why under name vapor power cycle? Because here the working fluid is water. The water will be converted from liquid phase to the vapor phase, and again from vapor phase to the liquid phase. Okay, it is a continuous process. So when the water is in the vapor phase, it will produce power. Okay, that is why it is also called as a vapor power cycle. See, this topic is very simple one, very simple one, and every year definitely you will get 2 to 4 marks in the examination. So you should not lose any marks from this. Before we go further and study about this, I would like to first recollect. We will do some recap of the basic concepts. Okay, so recap of basics. Okay, basics. See, in the thermodynamics we have already studied, especially in the properties of pure substances, we have studied different properties. What are those different properties? Different properties we have studied, and here in this chapter many times we use these terms. What are those? We use the isobar. Iso mean, what is the meaning of iso? Iso mean constant, always. Okay, constant pressure. Isobar means it is a constant pressure. Okay, isentropic. Iso mean constant, tropic mean entropy. Okay, so it is a constant entropy. Entropy is either capital S or small s. Small s indicates the specific entropy. Capital S is absolute entropy. So here, what is the unit of this? Can you recollect this? The unit of this, kilojoule per kg Kelvin. Okay, kilojoule per kg Kelvin. Okay, even if you are unable to recollect this units, then at least you should remember the formula. What is that? dq equal to TdS. dq equal to TdS. Okay, where dq is kilojoule and kilojoule per, actually this is a specific entropy, right? So kilojoule per kg and T is a Kelvin. So when this is coming to this side, then you will get the kilojoule per kg Kelvin for the entropy here. Okay, and most of the time we will use these two concepts here, and apart from this, we also deals with the enthalpy. What is the enthalpy? You already seen that enthalpy. Enthalpy is nothing but the the heat content. Actually, directly it gives the heat content or the ability of that particular fluid. Ability means ability to perform the work. Work or work in the sense the useful ability. Either it could be the heat or it could be in terms of the work also. Okay. So this enthalpy. H, what is the unit here? Kilojoule per kg. Most of the time, unless otherwise specifically mentioned, always it is a kilojoule per kg. All these are properties, right? All these are properties. And here one more thing we deal is dryness fraction. Dryness, okay, fraction. What is the dryness fraction? The dryness fraction, X is defined as the mass of the vapor divided by mass of the vapor plus mass of the liquid. Okay, so this is the dryness fraction. So most of the time we will deal all these 4. Okay, and apart from this, always we should be very comfortable with the TS and HS diagram. Mostly TS diagram in this chapter. Generally we are going to use the HS diagram, which is also called as the Mollier diagram, right? You remember, if you are unable to recollect, you just go back to our previous chapter and then in the thermodynamics and brush up your basics. So one is the TS diagram. TS, okay, temperature and entropy diagram. Okay, in the temperature and entropy diagram, we will take the liquid and the vapor region. For example, I will draw the TS diagram here. Okay, this is the TS diagram, T on the y-axis, S on the x-axis. Okay, so here which region should I represent here? Which region? See, in the Rankine cycle, the working fluid is water, and always the water is converting from liquid phase to the vapor phase, and again from the vapor phase to the liquid phase. Okay, so that is why here I will take the region which will capture my liquid phase and as well as the vapor phase under the combination of the liquid and the vapor. Okay, so here, so this is the shape of the curve, right? So instead of explaining too much, I just recollect all the points. So this is the shape of the curve. Here this is the liquid and this is the vapor phase, and this is the L plus V, liquid plus vapor here. Okay, this is the critical point CP, and this curve is called as the saturated line. Okay, so left side, since it is separating a liquid and a liquid plus vapor, then it is called as a saturated liquid line. I am also not writing these words. Why? Because we already studied this. Saturated liquid line, that word is important. And what's about this? This line is a saturated vapor line. Okay, that means if I take any point on this line, on this curve, that particular point is a saturated state. In the same way, if I take any point on this curve, that particular state is a saturated state here. Okay, so here most of the time we will deal with this diagram in this chapter. And apart from this, sometimes we will see the Mollier diagram also, that is also called as the HS diagram. Okay, H is on the y-axis and S is on the x-axis, and here in this case, the shape will be somehow like this. It will be like this. Okay, something, even it would be something like this also. Okay, it would be like this, and here this is the critical point here. Okay, so but here we mainly concentrate on this. And here in this TS diagram, okay, how will you represent the constant temperature line? Of course, the constant temperature line is like this, right? Okay, because at any temperature, if I draw the horizontal line, that is the constant temperature line. How will you represent the constant entropy line? Entropy line is, if I take any corresponding entropy, and if I draw any line, that is a constant entropy, or it is also called as the isentropic line, right? These two are fairly very simple. What's about the constant pressure line? How will you represent? Why? Because in the Rankine cycle, two are constant pressure lines and remaining two are constant isentropic line. So how to represent that? Constant pressure line is, for example, if I take any pressure, so it is going up to this point, and during the phase change, the temperature and as well as the pressure is always constant. Okay, that is why this is a horizontal line, and after that again, it will go like this. So this is a P equal to C here. Okay, so let's assume the P equal to C, let's assume this is a something like 10 Pascal. And if I want to draw P equal to 15 Pascal, then always it will be above this and parallel to this, and it will go like this. Okay, so this is a P equal to 15. Okay, if I draw the P equal to 5, then it will be less than this, it will go like this. Okay, so this is a P equal to 5 Pascal. So the constant pressure line is like this. What is the meaning of the constant pressure line? The meaning of constant pressure line means, for example, here at point 1, the pressure is 5 Pascal, and even at this point 5 megapascal, here also 5 megapascal, here also 5 megapascal. That means at any point, the pressure is the same. Understood? So here, let's assume that this is the 100 degree centigrade line. 100 degree centigrade line. Okay, so here this is the point A, this is the point B and this is the point C. So can you identify point A and point ABC in terms of temperature and pressure? So this is the temperature coordinate and this is the pressure coordinate. Okay, so point A, how will you write point A? Tell me. Temperature, how much temperature? 100 degrees centigrade, and then what is the pressure here for this? This is the 15. Okay, in the same way B, what is the temperature? Temperature is 100 and pressure is 10 here. Where is that? B is on this line, right? Okay, in the same way C, for the C, temperature is 100 and pressure is 5 here. Okay, so you might be thinking these are all very simple, already I dealt previously. Why I am spending this much time? Why? Because see here the entire chapter is revolving around identifying the properties and substituting the correct property values so that you will get the answer here. Okay, so this is the constant pressure line, and apart from this constant pressure line, one more thing we need to understand. What is that? One more thing you need to understand, that is the dryness fraction. So dryness fraction, what is the dryness fraction? Dryness fraction come into picture only when there is a phase. That means dryness fraction is between these two, right? So here, dryness fraction, if there is no vapor in the dryness fraction, then what happens? It will be 0. And if there is no liquid, then its value is 1. What I am saying is, if ME equal to 0, it will become 0. If ML equal to 0, it will become 1. That means here, dryness fraction here is x equal to 1, and on this line x equal to 0, and in between it will varies. Okay, and from the critical point, you can draw different dryness fraction lines like this. So what is the meaning of that? If I say that here x equal to 0.9, what is the meaning of that? On any point on this line, x equal to 0.9. That means the dryness fraction is 0.9. In the same way, this line, if I say that x equal to 0.8, x equal to 0.8, that means on any point on this x equal to 0.8 here. Okay, so this is the dryness fraction. Dryness fraction, what is happening from left side to right side? Its value is increasing. Okay, its value is increasing, and here, based on the dryness fraction, we will calculate the steam table. We discussed about the steam table. Okay, what are those steam table? In the steam table, okay, we will give different property values based on the temperature and pressure, and most of the time it is saturated, related to the saturated points. Okay, related to the saturated point. So for example, at this position, okay, I know the temperature and pressure, T and P are known. For that T and P, okay, so I can know the properties on this line and as well as the other line. So that means on this line it is called as the HF. Actually it is called as the HL, but somehow they are calling HF. Okay, what is the HF? The entropy of the the enthalpy of the liquid at this point. If I draw a line here, this is a Hg, G for gas. Okay, so Hg is on the, whenever I say HF or Hg, these are on the saturated lines, right? Okay, in the same way SF and Sg, these are also on the saturated lines. Okay, so on the saturated line in the means, at the extreme ends I can find out, but what's about at this point? Okay, if I want to find out at this point, how can I find out? Okay, I can find out by knowing the dryness fraction. Okay, dryness fraction. How is that? So here, for example, at that position, if I want to find out the enthalpy, H equal to HF plus X into Hg minus HF. Okay, in the same way, S equal to SF plus X into SG minus SF. Okay, so how this is working? See, for example, when X equal to 0, that means at this left extreme on the saturated liquid line, what is happening if I substitute this H equal to HF, right? So H equal to HF, and when X equal to 1, then what is happening? H equal to Hg. H equal to Hg. Is it satisfying? Yes, it is satisfying. In between, okay, in between, it will take the fraction of, fraction of, what is that? Fraction of the vapor with respect to the total amount, and then calculate. Okay, the difference between these two. So this is where you need to find out. Why I am introducing all this again, right? In most of the problems we are going to see on the same concept. Okay, so this is just like a what is that, recap. Okay, and here and many times we are going to see one more concept. What is that? We are going to see one more concept like isentropic line. Many times we will see isentropic line. So see, what is the isentropic line? The line which is having the same entropy. Okay, see, for example, this is the state 1 and it is going to the state 2. This is the state 1 and this is the state 2. Okay, so here if I say that process 1 to 2 is isentropic, what is the meaning of that? That means S1 equal to S2. Okay, that means S1 equal to S2. So S1 equal to S2. Okay, so when S1 equal to S2, S1 is a single region. There, S1 is in the vapor region, right? Vapor region. What's about S2? S2 is in the it is in the two phase region. Okay, it is in the two phase region. So whenever it is in the two phase region, how will you find out? Let's assume this is only up to this point. How will you find out the entropy at this point? I can find out entropy at these extreme ends, but how to find out at a 2 point? Okay, so for that S2 equal to SF at point 2. At point 2 means, what is the meaning of the point 2? The point 2 is corresponding to the temperature and the pressure at this point. Okay, this temperature and pressure, they will mention the temperature and pressure and they will give the steam value. From that I can substitute, right? So this SF, where is SF? This is the SF. Plus X, where is the X? X is the dryness fraction at point 2. So X2 I should find out. Once if I know the X2, then I can substitute these values. So here SF2 X2 into SG2 minus SF2. Okay, this is how I can calculate. Okay, this equal to S1. Okay, see here if S1 is given and these three are given, then from this I can find out a X2, right? Okay, sometimes we need to find out the X2 so that I can be able to find out the enthalpies. Okay, so for example here in the given question, they will mention like this. How they mention? They mention that entropy at this point. Entropy at this point is something like a 6.5 kilojoule per kg Kelvin. Okay, this is mentioned like this. At the point 2, whose pressure is, okay, saturated pressure is something like a 15 kilopascal, and the saturated steam values at this pressure is given. So and so. How they give? SF equal to 0.5 and then SG equal to, they will give 8.5. Okay, 8.5. If they give like this, of course the units are there. So if they give that, then how will you find out the X2? If it is isentropic line, okay. and process 1 to 2 is a isentropic line. Then what is the value of S1? S1 is a 6.5 equal to SF2. At point 2, SF is how much? 0.5. 0.5 plus AX2 into SG2 is how much? 8.5 minus 0.5. Then how much it will become? When it is coming here, X2 into, it will become 8, right? 8 equal to 6 because 0.5 is coming to this side. Then here it will become X2 equal to, 6 by 8, that means 3 by 4. It will be 3 by 4. Okay, 3 by 4 means X2 equal to how much? 0.75. Okay, X2 equal to 0.75. This is how you need to find out the the dryness fraction. Why you are finding the dryness fraction? By knowing this dryness fraction, I can find out the enthalpy. So enthalpy at the point 2, H2 equal to HF2 plus X2 into Hg2 minus HF2. Okay. Why? Because finally we need to find out the what is the work done and what is the heat transfer, all these concepts. Understood? So this concept we are going to use again and again, and we are going into the details, actual details. I may not spend that much time why we are doing all this. Okay, straight away I will take these points. Okay, so now we got some more basic understanding here. Okay, and we discussed about the Mollier diagram also. Yeah, on the Mollier diagram, okay, I will draw here. See, for example, in the Mollier diagram, for example, this will be something like this. Okay, this is the CP. Okay, and here how is the constant pressure line? Of course, the isentropic line is vertical one. Okay, and the constant pressure line will be like this. The constant pressure lines are like this. Okay. So, for example, if I want to draw the isentropic line, this will be as usual like this. This is the isentropic line here. Okay, and the constant temperature line will be something like this. But here anyway, the constant temperature line is not coming. So only the constant pressure and constant entropy lines will be coming here. But most of the cases we will deal the TS diagram only. But it's always better to know this also. Okay. So with these basics, we will go ahead and see and try to understand.